In the infinite expanse of the universe, where stars burn like eternal candles, a team of astronomers stumbled upon something extraordinary. Buried within ancient star patterns lay a map to a forgotten world, rich with resources that could redefine humanity's future. But every discovery comes at a price. As they decode the secrets of the cosmos, they uncover truths that challenge everything we know about our place in the galaxy. Are you ready to unravel the mysteries of the stars? Subscribe now and embark on a journey to the edge of reality. The observatory nestled in the Chilean Andes operated under the watchful eyes of Dr. Sarah Collins, whose dedication to astrophysics had earned her both admiration and skepticism from peers. The facility housed one of the most advanced telescopic arrays on Earth, capable of capturing light from the earliest moments of the universe. On this particular night, as the southern hemisphere's constellations stretched across the sky like an intricate tapestry, Sarah led her team through what seemed like another routine observation session. The air inside the control room carried the familiar hum of servers processing terabytes of data, while monitors displayed kaleidoscopic images of distant galaxies. Their research focused on mapping dark matter distribution across specific sectors of space, requiring hours of meticulous calibration and data collection. Each researcher moved with practiced efficiency, their movements synchronized like components of a well-oiled machine. Sarah monitored multiple streams of information, her trained eyes catching subtle anomalies that others might dismiss as instrument error. The telescope's adaptive optics system compensated for atmospheric interference, providing crystal-clear views of celestial phenomena billions of light-years away. As midnight approached, an unusual pattern emerged in Sector 47 Beta. What initially appeared as random noise began to coalesce into distinct geometric formations that defied natural explanation. These shapes shifted imperceptibly against the background stars, maintaining precise angles and distances that suggested deliberate placement rather than cosmic coincidence. The team's excitement grew as they realized these weren't mere optical illusions, but actual structures embedded within the stellar configuration, hinting at intelligence far beyond human comprehension. The following days transformed into an obsessive quest for understanding as Sarah's team dedicated every available resource to analyzing the mysterious patterns. They employed sophisticated algorithms designed to detect artificial structures in space, tools originally created for searching extraterrestrial megastructures. The results confirmed their initial suspicions. The formations possessed mathematical precision that couldn't be attributed to natural processes. Prime numbers and Fibonacci sequences intertwined within the patterns, creating a complex code that spanned multiple star systems. Each new piece of data revealed additional layers of complexity. The patterns responded to their observations, shifting slightly in response to Earth's movement through space while maintaining their fundamental structure. This interactive quality suggested the map wasn't merely a static artifact, but an active system designed to guide those who could decipher its language. The team worked around the clock, their exhaustion tempered by the thrill of discovery, as they uncovered coordinates pointing toward a specific region of space approximately 300 light-years from Earth. The implications extended beyond mere navigation. Embedded within the primary map were secondary patterns containing detailed environmental data, suggesting the creators intended recipients to understand not just how to reach their destination, but what to expect upon arrival. Certain pathways were marked with warning symbols translated through mathematical relationships, while others displayed indicators interpreted as resource availability or environmental stability. The map's sophistication indicated its makers possessed knowledge of physics and mathematics far exceeding current human capabilities. As weeks turned into months, the team developed increasingly advanced methods for interpreting the map's intricate language. Dr. Michael Chin, a specialist in computational astrophysics, created a neural network capable of translating the geometric patterns into usable navigational coordinates. The system resembled ancient Polynesian star charts in concept, but operated on an astronomical scale incomprehensible to previous generations. Each coordinate corresponded to specific points in space, forming a web-like structure that extended across dozens of star systems. The decoding process revealed additional layers of information embedded within the primary map. Temperature readings, atmospheric compositions, and gravitational data accompanied each set of coordinates, painting a comprehensive picture of the journey ahead. Most intriguing was the convergence point of these coordinates, a specific location orbiting a G-type main-sequence star remarkably similar to Earth's Sun. The distance and positioning suggested the possibility of habitable zones, though the map's warnings hinted at conditions that might prove challenging for human exploration. Mathematical analysis exposed a fascinating aspect of the map's design. It employed a combination of universal constants and localized reference points, making it accessible to any sufficiently advanced civilization while remaining invisible to less developed observers. The team discovered encoded messages within the patterns themselves, using prime number sequences as delimiters between different types of information. These messages contained not just directions but descriptions of potential hazards, recommended approach vectors, and even suggestions for optimal timing based on stellar alignments. Securing funding for such an unprecedented mission required navigating complex international politics and scientific bureaucracy. Space agencies from multiple nations contributed resources, each hoping to claim a share of whatever discoveries awaited while maintaining plausible deniability should the expedition fail. A modified exploration vessel, originally designed for asteroid mining operations, underwent extensive upgrades to handle the long-distance journey. Its nuclear fusion propulsion system received enhanced shielding, and additional fuel reserves were installed to account for the extended travel time. The spacecraft's scientific payload represented the pinnacle of human engineering. Advanced spectrometers could analyze planetary atmospheres from orbit, while ground-penetrating radar systems prepared to map subterranean structures. Biological detection equipment incorporated cutting-edge nanotechnology capable of identifying both known and unknown organic compounds. Multiple redundant communication systems ensured constant contact with Earth, though the increasing distance would eventually introduce significant delays in transmissions. Safety protocols multiplied as the team considered every conceivable scenario. Radiation protection measures exceeded standard specifications, given the unknown nature of their destination. Emergency supplies were tripled, including life support reserves and medical equipment capable of handling both conventional and exotic injuries. The crew selection process emphasized versatility, resulting in a team of experts trained in multiple disciplines, from xenobiology to exogeology, all prepared to encounter phenomena beyond their current understanding. The launch sequence initiated with calculated precision, each phase of ascent monitored by dozens of ground stations worldwide. As the vessel broke free from Earth's gravitational embrace, the crew experienced the familiar weightlessness of space travel, yet this journey felt fundamentally different. Their destination wasn't a predetermined point in local space, but a convergence of coordinates pointing toward mysteries older than human civilization. The ship's enhanced propulsion system accelerated smoothly, its fusion engines humming with controlled power as they carved through the solar system's outer reaches. Crossing the Kuiper Belt marked the transition from familiar territory to genuine exploration. Here, the density of known objects thinned dramatically, leaving the ship surrounded by vast emptiness punctuated only by occasional distant pinpricks of light. The star map's guidance system proved invaluable as it automatically adjusted course to avoid dense asteroid fields and rogue planetesimals. Instruments detected subtle gravitational anomalies that might have gone unnoticed without the ancient map's warnings, confirming the sophistication of its creator's knowledge. Months passed in the rhythmic pattern of deep space travel. The crew maintained their routines, alternating between periods of intensive study and necessary rest. Through reinforced viewports, they watched as constellations slowly shifted, their familiar patterns dissolving into new configurations. The destination star grew imperceptibly brighter each day, its light carrying hints of the mysteries awaiting discovery. Periodic course corrections, guided by the map's increasingly detailed instructions, kept the vessel aligned with its target. The final approach to the destination star revealed details that sent waves of excitement through the crew. Spectrographic analysis identified a planetary system with 3 major bodies orbiting the central star, but it was the second planet that matched the map's coordinates perfectly. Its atmosphere showed unusual chemical signatures, traces of rare elements combined with complex organic compounds that shouldn't naturally occur together. The planet's size and position within the habitable zone suggested conditions potentially suitable for life, though sensors detected radiation levels higher than expected. As they entered orbit, the true scale of their discovery became apparent. The planet's surface displayed geometric patterns visible even from space. massive structures arranged in perfect symmetry across entire continents. These formations reflected sunlight in precise wavelengths, creating a shimmering effect that pulsed rhythmically, almost like a heartbeat. The phenomenon suggested either incredible natural geological processes or evidence of technological intervention on a planetary scale, raising questions about the civilization that might have created or utilized such structures. Detailed scans revealed underground networks extending hundreds of kilometers beneath the surface. Mineral readings indicated deposits of materials previously unknown to science, their molecular structures defying conventional physics. The planet's magnetic field exhibited peculiar properties, generating protective shields that fluctuated in response to solar activity. These characteristics pointed to either advanced terraforming technology or natural evolutionary processes operating under principles yet to be understood by human science. As the spacecraft entered low orbit, the crew deployed an array of remote probes designed to gather preliminary data without risking direct contact. These autonomous drones descended through the planet's atmosphere, their sensors recording every detail of the descent. The air composition proved breathable with modifications, higher oxygen levels than Earth's, but containing trace elements that required filtration. Temperature readings indicated a stable climate, though electromagnetic interference created unpredictable weather patterns that danced across the surface in mesmerizing displays of light. The geometric structures visible from space resolved into vast complexes of crystalline towers, their surfaces refracting sunlight into rainbows that painted the landscape. These formations weren't random. They followed precise mathematical relationships similar to those found in the star map. Some structures pulsed with internal energy, suggesting either active mechanisms or natural processes mimicking technology. The underground networks revealed by earlier scans connected these surface features through a labyrinth of tunnels and chambers, creating a planetary-scale system that defied conventional understanding. Initial mineral analysis confirmed the presence of unique compounds never before encountered. Elements formed bonds in ways that violated known chemical principles, yet remained stable under local conditions. Certain materials exhibited properties that could revolutionize energy production and material science. Superconductors operating at room temperature. Alloys lighter than aluminum but stronger than diamond, and energy-absorbing crystals capable of storing vast amounts of power. Each discovery raised more questions about the planet's origins and the civilization that might have engineered such wonders. Surface exploration began with cautious steps as remotely operated vehicles ventured into the crystalline complexes. The structures responded to their presence, walls shifting imperceptibly to reveal hidden chambers and passageways. These movements weren't mechanical in nature, but seemed to follow organic growth patterns, as if the buildings themselves were alive. Bioluminescent patterns illuminated interior spaces, creating environments that merged architecture with living organisms in ways that challenged fundamental definitions of life and technology. Within these chambers, the team discovered artifacts that appeared both ancient and advanced. Smooth, black obelisks stood in precise arrangements, their surfaces covered in etched symbols that resonated with the patterns found in the star map. When scanned, these symbols projected holographic displays showing astronomical charts and molecular structures. The information wasn't static but evolved in real time, adapting to observer presence and responding to queries posed through mathematical relationships rather than traditional language. Most astonishing was the discovery of what appeared to be manufacturing facilities still operational after unknown millennia. These installations produced the unique materials detected earlier, utilizing processes that combined biological and technological elements. Nanoscopic machines worked in harmony with organic components, creating resources through methods that blurred the line between natural growth and artificial production. The efficiency of these systems suggested a civilization that had mastered sustainable development on a planetary scale. Despite the wealth of knowledge unfolding before them, warning signs began manifesting in subtle ways. Crew members reported vivid dreams filled with complex mathematical equations and geometric patterns. These visions grew more intense with proximity to certain structures, particularly the black obelisks. Medical scans revealed unusual neural activity patterns matching those observed in individuals exposed to strong electromagnetic fields, though no such fields registered on their instruments. The phenomenon suggested the planet's influence extended beyond physical materials to affect consciousness itself. Environmental anomalies became more pronounced as exploration continued. Time measurements showed slight discrepancies near certain locations, with clocks advancing or retreating unpredictably. Spatial orientation occasionally failed, causing distance perceptions to warp subtly. Instruments recorded gravity fluctuations that shouldn't occur naturally, creating zones where objects moved differently or maintained positions against expected physics. These effects intensified around the largest crystalline structures, hinting at technologies or natural forces manipulating fundamental physical laws. The team faced difficult decisions regarding how deeply to investigate these phenomena. While the potential benefits for humanity were immense, the risks associated with interacting with such advanced systems grew increasingly apparent. Every new discovery brought both wonder and unease, forcing them to balance scientific curiosity with caution. Protocols tightened around which areas to explore and how much time to spend in potentially hazardous zones, though the temptation to uncover more secrets constantly tested these limits. The black obelisks proved to be repositories of information far more sophisticated than initially understood. Their holographic projections revealed detailed records of the planet's history, though interpreting these required developing entirely new methods of decoding. The civilization that created this world hadn't merely advanced technologically but had evolved beyond traditional biological constraints. Their consciousness existed simultaneously in physical and virtual realms, allowing them to manipulate matter and energy at fundamental levels. These beings had transcended mortality not through medical advancement alone, but through integration with their environment. The crystalline structures served as both habitat and computational matrix, hosting consciousness patterns that persisted long after physical bodies ceased to exist. This explained why so many systems remained operational despite apparent abandonment. The planet itself functioned as a distributed intelligence, maintaining its creator's legacy through automated processes guided by embedded protocols. Understanding this revelation required rethinking basic concepts of life, death, and evolution. The civilization hadn't disappeared in the traditional sense, but had transformed into something beyond human comprehension. Their death represented transition rather than termination, leaving behind a world that continued to operate according to their final instructions. The resources being produced weren't mere commodities but components of a larger system designed to sustain their post-biological existence while potentially aiding other civilizations that might find their way here. The implications of this knowledge stretched human understanding to its limits. The materials and technologies discovered offered solutions to countless earthly problems: unlimited clean energy, revolutionary medical treatments, advanced computing capabilities. Yet implementing these discoveries required overcoming significant challenges. The manufacturing processes depended on environmental conditions unique to this planet, making replication elsewhere extremely difficult. Transporting materials back to Earth risked contamination or destabilization due to differences in gravitational and electromagnetic fields. The team developed innovative methods for safely extracting and transporting samples, creating specialized containers that mimicked local conditions. These vessels utilized principles learned from the planet's own systems, combining biological and technological elements to maintain stability during transit. Small-scale experiments demonstrated promising results, with materials retaining their extraordinary properties even after removal from their native environment. However, scaling up these processes required careful consideration of potential consequences both on Earth and for the planet itself. Ethical considerations weighed heavily on their decisions. Removing resources from a world that essentially served as a monument to an advanced civilization felt uncomfortably like grave robbing. Yet ignoring such opportunities might represent a failure to honor the creator's apparent intent to share their knowledge. The team worked to establish guidelines for responsible utilization, ensuring any benefits gained contributed to peaceful progress rather than conflict or exploitation. As research progressed, certain actions triggered unexpected responses from the planetary system. Accessing deeper levels of the obelisk's databases activated mechanisms that had lain dormant for eons. Massive structures began transforming, revealing additional layers of complexity beneath their crystalline exteriors. These changes occurred with mathematical precision, following patterns recognizable from the star map but operating on scales that dwarfed previous observations. The planet's response suggested a form of awakening. not necessarily of intelligent beings, but of automated systems designed to assess visitors' worthiness. Challenges emerged in the form of environmental tests, creating situations that required applying recently acquired knowledge to survive. Weather patterns shifted dramatically, electromagnetic fields intensified, and gravity fluctuations became more pronounced in specific regions. Success in navigating these trials granted access to additional information and resources, while failure resulted in temporary isolation from sensitive areas. This process forced the team to demonstrate their understanding and respect for the planet's systems. Each success built upon previous knowledge, creating a feedback loop of learning and application. The challenges weren't merely tests of intelligence, but of wisdom, requiring careful consideration of actions' consequences and willingness to work within established parameters rather than attempting forceful domination of encountered technologies. The cumulative effect of these experiences transformed the expedition from mere scientific exploration to cultural exchange on a cosmic scale. The team developed protocols for interacting with the planetary intelligence, establishing communication through mathematical and physical relationships rather than traditional language. This method proved remarkably effective, allowing them to ask questions and receive answers in forms comprehensible to human minds, yet preserving the original sophistication of transmitted knowledge. Certain areas open to them contained preserved records of the civilization's achievements and mistakes. These archives revealed a society that had faced challenges similar to those confronting modern humanity: resource management, environmental sustainability, technological ethics. Their solutions, while not directly applicable to Earth's situation, provided valuable insights into approaching such issues from different perspectives. The experience of witnessing another species' path through similar evolutionary pressures offered unprecedented perspective on humanity's own trajectory. The relationship evolved into a form of mentorship, with the planetary system guiding researchers through increasingly complex concepts while monitoring their ability to responsibly handle gained knowledge. This process accelerated discoveries while ensuring safeguards against misuse or misunderstanding of acquired technologies. The team found themselves not just explorers, but students in a cosmic classroom, learning lessons that would shape humanity's future interaction with the universe. The journey back to Earth carried more than physical samples and recorded data. It brought profound changes in perspective and purpose. Each member of the expedition returned transformed by their encounter with a civilization that had transcended conventional limitations of biology and technology. Their understanding of what constituted life, intelligence, and progress expanded beyond anything previously imagined, challenging fundamental assumptions about humanity's place in the cosmos. Implementing their discoveries required navigating complex political, economic, and social landscapes back on Earth. The knowledge couldn't be simply handed over, but needed careful introduction and explanation to prevent misuse or panic. Specialized teams worked to translate advanced concepts into practical applications while developing educational programs to prepare society for the paradigm shifts ahead. The task proved monumental, yet essential for ensuring humanity could benefit from these discoveries without repeating past mistakes of technological advancement outpacing ethical considerations. The experience fundamentally altered humanity's approach to space exploration. No longer did stars represent empty voids waiting for conquest, but potential connections to other intelligences, both biological and post-biological. The star map that led to this discovery took on new significance as possibly one of many such guides scattered throughout the galaxy, each waiting to share its creator's legacy with those ready to receive it. This realization sparked a global movement toward more thoughtful, respectful exploration of the cosmos. Years later, the impact of the expedition rippled through every aspect of human civilization. Technologies derived from the forgotten planet revolutionized multiple fields while forcing society to confront difficult questions about progress and responsibility. The materials and knowledge gained became foundations for addressing Earth's most pressing challenges, from climate change to resource scarcity, but their implementation required constant vigilance against unintended consequences. The planetary intelligence's guidance continued through carefully maintained protocols, ensuring humanity's development aligned with principles of sustainability and ethical advancement. The star map's discovery inspired a new era of astronomical research focused on finding similar guides hidden among the constellations. Observatories worldwide coordinated efforts to search for patterns that might lead to other lost civilizations or forgotten worlds. Each potential candidate generated excitement tempered by the knowledge that true understanding required patience and respect rather than haste and greed. Humanity's place in the universe transformed from isolated inhabitants of a single planet to participants in a vast network of cosmic heritage, each discovery adding to the collective wisdom of countless civilizations. As new generations of explorers prepared to venture beyond Earth's solar system, they carried with them the lessons learned from that first encounter with the forgotten planet. The journey had shown that true progress came not from domination of the unknown, but from harmonious integration with greater cosmic truths. The stars, once distant points of light, now represented potential connections to infinite possibilities, each waiting to share its story with those wise enough to listen and learn. Remember to subscribe for more incredible journeys into the mysteries of our universe.